Yes. Mr. Myers has now started the recording and is dusting off his screen. He takes a sip of water. Describe video. Oh, anyway, okay. So, first question. There are a lot of words that you guys may have written in this blank, all of which will be dancing around the right word. Okay? Or word z. Jack.
Linear relation.
Okay. Good answer. A linear, just give me a second. If the question was this, a blank represents two quantities that change in relation to each other at a constant rate. Jack is perfectly correct. But that's not the question. The question says, what on a graph shows that? A straight line. Jack, not everything is bimodal, okay? Just chill for a second. Jeez. So, Jack said a linear relation. Yes, if you put a linear relation on a graph, it will do these two things. But the best answer would be a straight line, okay? But it's a review, so you get credit for knowing something about it. So I will take linear relation. I will take linear function. What I will not, I will take straight line. Straight line is the best thing you could say. What I will not, what shows me you do not understand it is a line, because this is a line on a graph. Is that a linear? No. Does that change in relation at constant rates? No. So you can't just say a line, right? And then there's this is also a line. That's not changing at a constant rate. Okay, and if you just say function, this is a function. Does that show me change at a constant rate? All right, so I needed to hear something about a line to get the full mark. The best mark is, of course, a straight line. Okay, you guys have the bad luck of having this class in the afternoon, which means I've put up with teenagers the entire day. And 2 to 3 times a week, you were in this class last, which means I am at the end of my day of putting up with teenagers. Which means my patience is worn thin. My patience is worn almost as thin as your attention span. Okay? So I'm going to try to be pleasantly, positively reminding of how I need you to be. Okay? So I'm not going to do the negative thing. I'm going to do the positive thing. Why don't you guys pay attention to your review and mark it? Okay? Okay. And of course, I like to use iMessages as well. I would like it if you would do that. All right? Now let's see how long that holds. A graph whose points are not connected represents what kind of data? Discrete. And a graph of what kind of data has no space between the points? Continuous. All of that is worth 1 mark each. Therefore, the first bit is out of 3. I have 3 out of 3. I hope you do too, because I will be giving I messages today, not you messages. Now, yes, discrete and non-continuous are the exact same thing. The math word is discrete. If you wrote non-continuous, you may still have the mark because, of course, that means you understand them. Next, what of these 7? Now, this is always a problem because kids are like, Mr. Myers, there's 7 choices but only 6 questions. Because, of course, you don't read the instructions. But that's okay. What of those 7 words measures the steepness of a line, do you think? Jack?
D. Slope.
D. Slope. Well done there. A relation in which any value of the independent variable is related to one value of the dependent variable. What kind of relation is that? Oh, Sam. A. It is a function. Abso-smurfly correct. If a line crosses the horizontal axis, what is it, Josh? It is indeed an x-intercept because the horizontal axis is the x-axis. Any association between 2 quantities. A relation, C. A formula or rule that defines a particular function. So one specific function. Function notation, B. It could be the f of x or it could be the g of x. The f and the g say they are different. And number 6, how do we determine if a relation is a function? E, the vertical line test. When does that work? What is the what? When it is graphed. Does the vertical line test help you if it's in a table? No. Mr. Martins. Oh, of course, yes. AX, QX. The letter is just the name. When you get a little older, you'll be doing crazy things like F and F prime of X.
Oof.
And those two are related, but different. But that's for another day, not for grade 10, so let's not borrow problems from the future. Now, this next one caused a bunch of trouble in my other class, because they were like, what? And I was like,
Go.
when there were some choices, there were questions after it, right? They were like, yeah, okay. There's some choices, and there's some questions after them. They were like, that makes so much more sense. And I said to them all, I said, what did you do with 7, 8, 9, and 10? And they said, I don't know. So anyway, but there was a mistake. You guys, if I am not mistaken, have a little squared right there.
Yes.
You're not supposed to.
Yes.
It was supposed to be blank. Because if there is a squared there, there is no domain and range for it. Okay? We'll talk about that in a second. But right now, we'll do this properly. If that square was gone, and I told you to take the square out, did I not?
Yeah.
Okay. What is the domain and range of that function? B, all real numbers. Because can you not take every single number in the whole universe, multiply it by 3, and then take away 4 from that number? Yes. So it is everything. Right?
Is that what the E means?
Yes.
Sorry, I didn't know.
Yes. The E, you guys have seen that E right here. I am the worst kind of liar. You have seen that E right here. Right here. Right. Maybe you guys hadn't seen that E. The other kids had seen that E. I feel bad now. But yeah, that's what that E means. I thought I had shown that to you guys. Now, just to prove I am not a crazy man. See? The other kids had seen the E.
No, you've done that too.
I thought I had
Sometimes.
at some point or another, but I said you didn't have to really worry about it. Because you don't, right? Right? So, now, 8 was tricky. What are the two things being counted? Time and height. Which one of those is independent? Time, which means which is the domain? Time. What is the lowest time you can have ever? 0. What is the highest time in this question? 4. So the domain must be the one that goes from 0 to 4, yes? Okay. And the range, what's the lowest height you can get? 2. And the highest? 13. So I need a domain that's 0 to 4 and a height that's 2 to 13. It is, look closely, the domain is 2 to 13. It's got the right numbers, but it's not in the right spot, is it? The range is 2 to 13. So it's E. E. Number 9. Harsimran. What's the lowest domain value in number 9? You can do it. You could give me the answer if you want. A. It is A. Oh, I don't know. Let's check.
I think both of them work.
Both of them are, oh, no. Simran. High is so 5. It is A. Why doesn't C work? Look closely.
There's a big Papa E right there.
What do you see there?
Ah, shoot. Hey.
That says less than. Does it say equal to? No. What does that bracket mean? Because, of course, you can quite plainly see the line gets to -2. There is no open dot there. And number 10 is B, because you can take any number in the entire universe, cut it in half, and add 6 to it. That's out of 4. Okay, now, guys, this question asks you to describe a possible scenario. Now, some of you, English is not your first language. Some of you are not best-selling authors. Some of you just don't like writing stuff down. Is this a math class?
Yes.
Is this an English class? No. Do I care how well your scenario is written? No. But do you have to tell me something? Yes. Excellent. Would you like to go first, Jack?
Sure.
Go ahead.
Okay, so.
Oh, wait, Jack, I'm sorry. Put a pin in that. Because I wrote this question very badly on purpose to see if anybody would correct me. What is wrong with the question? Not the graph and not the answer. Something is wrong with the question. Kilometers is okay. Now I had to check. Maybe I screwed that up. Okay. Whoa. Sarah was next. It says distance time, doesn't it? And what happened right there? I'm going back. So what should that say? Displacement. It could even say distance from start or something like that. But to call it a distance time graph, that's technically not very good, is it? because distance is a magnitude, and it should have continued to go up, right? Now, yes.
Could you say it as, say the kilometers is like, I don't know how to explain it, but saying it's filling, something's filling up with something, but over time it's filling up, and then all of a sudden, let's say the bottle cracks, whatever, and just empties, and then the stuff in it just goes down. Could you say it as that?
But volume or capacity of something in here is not it's not a vector. Or I'm sorry, it is a vector, right? Because if I put a hole in this, the volume does decrease, right? But if I had a little cork floating in there on the bottom and I filled it up, that cork would go up, 7 inches? And then it would go down 7 inches. So the cork would have traveled 14 inches, even though it went up and down. And I don't know if we're on the same page here.
Exact same thing, but don't worry about it.
Okay. Jack, start us off, please.
Okay, so each point I labeled as the first one's A, the second one's B, the third's C.
So A, B,
No, starting at the very bottom.
starting at the very bottom. So Jack went A, B, C, D. So he is going to have to tell me to do his scenario. It's going to have 3 parts to the story. Yes? Great. So
from A to B, Ronald rides his bike for 15 minutes.
No, keep going. I'm
It
telling.
takes him 2 kilometers. Takes 15 minutes to ride 2 kilometers.
Okay. Now, Jack has told me a story. Yes? Ronald has ridden his bike 2 kilometers in 15 minutes. Are we happy with that?
Yeah.
Sure we are. Right? Is that what's happened? Yes. Now, if I were given him 1, 2, 3, 4, 1 being limited understanding of what is going on, 2 being basic understanding of what is going on, 3 being an a comprehensive understanding of what is going on, and 4 being an advanced explanation of what is going on. What do you think that would get? Ronald rode his bike 15 minutes, or 2 kilometers in 15 minutes. You think that's a 3? I agree, that's a 3. How could he make it a 4?
At a constant speed.
Constant speed. What else could he do? What direction was he going? He rode his bike up,
A mountain.
away from home, right? Okay, and he rode 15 minute, 2 kilometers in 15 minutes. Is that how we do speed? No. We always do our speeds per single units, right? So we could have done kilometers per minute or kilometers per hour, right? We never do that. So Jack's sitting really comfortably at a 3. If he wants that 4, he would have had to show me more understanding of what is going on. Does everybody understand?
He's riding 8 kilometers an hour.
Yes, he is indeed riding 8 kilometers an hour. I'm about to talk about that. So, Jack, everybody sees how Jack's right? He went 2 kilometers, or he went 2K in 15 minutes, yes? So we remember that a speed is always a distance over a time, right? Kilometers per hour. So he's gone 15, sorry, I lie. He's gone 2 km in 15 minutes. Now you asked Tasha, how do I make this kilometers per hour? Okay, well that's just a fraction, isn't it? How many minutes are in an hour? 60. So my new denominator is 60, right? In fractions, if I want to change it, I got to multiply, right? So 15 times what is 60? 4. So if I do something to the denominator, what do I got to do to the numerator? Same thing, times 4, so it's 8 kilometers in 60 minutes. which is 8 kilometers per 1 hour. You with me? Okay, so Jack is sitting at a good solid, in the new way of marking things, he's sitting at a good solid 3 so far, right? Okay, would you like to continue, or would somebody else like to take over for the second part? Or are we going to let Jack rock it out to the end? Okay, Jack, hit us. What you got?
So then a big dog starts chasing him.
Okay, big dog starts chasing him. Nice.
So he goes really fast and bikes 4 kilometers in 15 minutes.
Okay, so how's he doing? Is he still at a 3?
Yeah.
He's covered that he's sped up because the line got steeper, and he's given me a speed. What's the only thing that would make it a 4?
16 kilometers down.
He's doubled his speed, right? Because he's gone the same amount of distance in half the time. Yeah? Everybody cool? Okay, so A to B, and Tasha, did he do that at a constant? Right. So Tasha has the constant. Everybody cool? So it's away from home. It's at a constant speed, and the speed is 15 kilometers. I keep doing that. 2 km per 15 minutes, which is also 8 kilometers an hour. Everybody cool? Everybody happy with that being worth a 4? Now in my class, question's going to be out of 3. So Jack's cruising along, right? Okay. Just wait. B to C, we have, he's still going away. He's still going constantly. But he has now gone 2 to 6, which is 4 km in 15 to 30 in 15 minutes, which is doubled now to 16 kmh. And Jack has gone so far as to prove he has an advanced understanding of what is happening in the real world from this graph that he has even added a reason for going faster. Okay? Is there a right or wrong reason? No, it could be a big dog chase him. It could be he's going down a hill, right? If he got hit by a bus, I hope the bus does not drag him 4 kilometers at only 16 kilometers an hour. That would be very, very painful for everyone involved. Jack stuck to the windshield and the bus driver just going, loo, at 16 kilometers an hour. All right, is everybody cool with B to C? Okay, Jack, finish this off, please.
Okay, so then he realizes that he's late for dinner, so he puts on the hustle and rides his 6-kilometer bike home in 20 minutes.
He goes home, again constant, he goes from 30 to 50, so he goes 6 km in 20 minutes now, right? Because it's 30 to 50, which is 18 kmh. So he goes home faster. Is everybody cool? Now, as long as you have, for me, to get my 3 marks here, I need to see something about the constant, something about the fact that he speeds up at some point, and something about the fact that he turns around and goes home. And I would give you your full 3 marks. Does everybody understand? Now, that's not going to fly in 2 or 3 years, right? By the time you guys graduate, you're going to need to be doing stuff like this. Okay? 3 marks. Everybody cool?
What would my mark be? Just so I have to think. 2?
I'd probably give you somewhere between 3 and 4. All right. Is this linear? Yes or no? Yes. Why? You get 1 point for the yes, and now I need a reason. Josh. You're not Josh. Up 2 over 1, up 2 over 1, up 2 over 1, and it repeats. Right? So that's where you get your other one for your reason. The reason, right there. Up 2 over 1. It is a repeating pattern. 2 marks there. What about this guy? Is that guy linear? Nick. Is that guy linear? No, non-linear. Why? Because he's got an exponent. Yep. Because if you've got an exponent, it's going to go up. The first time it goes up, it's going to go up by 1, isn't it? Because 1 squared is 1. The second time, what's it going to go up by?
We go up to 4.
4 times, because 2 squared is 4. Third time, how much is it going to go up?
8 by 5 to 9.
Times it's squared.
Yeah. Third time, x is 3. 3 squared means it's going to go up
To 9.
9. Fourth time,
We go to 16.
16.
Oh, I see.
Picking up what I'm putting down?
You said we use.
I didn't understand that question, but I mean, bam.
Do you understand now? Here's why. Watch.
But like, I was thinking about like how to graph it, and I was like,
Yeah, it's exactly how you graph it. If I start at 0, 0 squared is 0, right? So on my x-axis, I'd be at 0, and I'd still be at 0 on y, right? If I go over 1, then I'm going to go up 1, right? Because 1 squared is 1. So if this was a line, the next one would be over 1, up 1 again, wouldn't it? But it's not. When I go over 2, it's squared, so I'm really going up 4. When I go over 3, I'm really going up 9, and it's making a curve. Cool? Tasha, I got to tell you, last year, with that exact description, you still would have gone, I can't do math. And today, okay. And not the, fine, okay. The actual, okay. And this one, linear or nonlinear? How could you check? It's not graphed. So what would you do? TJ.
see how much goes up or down each time.
Yeah, you'd make your table, right? So what are the x's? -2, 1, 4, 10, right? What are the y's? 5, 3, 1, -3. So let's check. That went up by 3, right? -2 to 1 is 3, correct? What's that? Down by 2. Everybody cool? So, if it's linear, these two numbers are going to repeat. What is 1 to 4? Plus 3. What is -2? Are we linear? Now what happens here? I went up by 6. So if it's linear, if this doubled, this should do what? Double. Did it? 1 down to -3. Isn't that 4? -4. So it doubled. So is it linear? Yes. Everybody good? So that's 2 marks, making that part out of 6, making that whole page out of 6, and 4 is 10, and 3 is 13. My computer's frozen, so I'm going to take a sip of water in order to keep calm.
No. You give explanations. That's what you said. Silly goose. No. No.
Everybody good? Okay, now, I messed with your head a little bit here, and I asked you for domain and range, but I asked you to write it in 3 different ways. One of which I never even taught you, personally, because you were all in a grade 3 class that had a number line on it around the roof, didn't you? Right? Okay, so, what are the domain and range? And I do my domains in blue and my ranges in red for this. Where do I look for domain? X or Y? X. So, I look at only the x-axis. Where do I start? At the lowest or at the highest? At the lowest. So I look only on the x-axis and I see there's a dot, so there is 1 right there.
0.
What is the next x value? 1. What is the next x value? 2. What is the next x value? 3. And then it ends, right? 0, 1, 2, 3. So on a number line, what would that look like? 0. Is 0 included? So I put a closed dot. Is 1? So I put a closed dot. Is 2?
Sorry for the interruption. At this time, could students, actually teachers of grade 9 students, please send a runner down to the office to pick up immunization forms to hand out to the students. So
None of you are grade 9s, are you?
one runner
None of you are
to
here.
the office to pick up immunization forms. Thank you.
Okay. So now, where do I look for the ranges? Simran, where do I look for range?
On the line. It was for her, Simmer, not you, Sam.
Other way. Go the other way. We already did the X. There you go. Do I start at the lowest Y or the highest Y? Lowest Y, which is right there. What number is that? Look again. -2. What number is that? 0. What number is that? 2. What number is that? 0, 2, 4. So what does it look like on a number line? What's the lowest number? -2. Next one, 0. Next one, 2. Next one, 4. And it's going to look like that. Everybody cool? Now, guys, I know you all know what a number line is. I know I should be able to say, if you didn't draw a number line, you get it wrong. Am I going to do that to you? No. But I would have liked to have seen a number line. Everybody cool? Okay. So, that's going to be worth, let's call it 1. 1 for all of it. If you only got the domain right, take a half. You only got the range right, take a half. Everybody cool? So as long as you have that written somewhere that the domain is 0, 1, 2, 3. Are you allowed to have this, though? Am I allowed to do that? No, because it's not solid.
Sorry, what's it on?
1, just 1. If you got one of them, you get a half mark. If you got neither of them, you get 0 for that question. Just for 3A. Now we're going to do B. B is tricky. It's messing with your head. Which of those is the independent variable? R. So R is the domain, yes? Excellent. Now, what shape does that formula refer? A circle. What is the smallest radius I can have of a circle? 0. I got no circle drawn on here, do I? So what's its radius? 0. So my domain, which I do in blue, must be 0 must be the smallest number. Can I have 0? So it must be equals 0, right? And that, what goes here? X, D, R, Q, P, R. And what's the biggest circle I can have? Infinite. I could have a circle as big as infinity because we don't know how far that goes. Now, the question becomes this. Is there another way to write that? Without the infinity symbol. Who remembers? You don't have to write it that way, but it's just shorter. Huh? No, because I did say set notation. You got to keep the arrows. But if it goes from 0 up to infinity, then isn't R greater than or equal to 0? Everybody cool? I would take either one of those. Everybody cool? And then the range is really tricky. What's the lowest range value I can have? 0. What goes here? Y. What can I go up to? Infinity. And how else could I write it? Y must be greater than or equal to 0. I'll accept either of those for that one mark. Is everybody cool? And then this one, it's just a list. This one's going to mess you up. I guarantee if you get anything wrong in this section, it's going to be this one. Who thinks, even though I have just given you the warning that it's tricky, who thinks they've done it right? and wishes to risk it. The big risk of me saying yes or no. It's not like back in the day when you might get punched in the mouth. Sam, you're going to risk it? Yeah. Okay, so what are my domains? 1, 4, 10. Is he right? Is he right?
I'm going to say yes.
Yes, he is. He's got the lowest number on the left, and he's listed them. Yes, on domain.
Yes, Sam won.
Would you like to try the range? Or are you backing out?
I can do a range.
You can do the range, okay? Hit me.
-3,
-3,
5.
1, 3, 5. Is he right?
Yes.
Yes, he is. Well done. He did not fall into the trap of keeping the ordered pairs together. Did anybody fall into the trap of keeping the ordered pairs together? Couple of you? So it goes. That's all right. That's all right. Okay, so that's worth 1, making that whole section worth 3. All right, so 4A, I got to write a function, my very own function. How do we write a function? Well, I got to decide on my what and what. My domain and range. What's the domain? That means I'm counting two things, right, Nick? What are the two things that I am counting? What are the two things I'm counting in that story? Cost and number of games played. Which one of those is independent?
I got this. Number of games played.
Number of games is independent. So games is over here. Because the more games I play, the more money I pay. Cost depends on games, right? So over here is cost. Now, you may not be wrong yet. Just stay cool.
Is it wrong if you didn't do this?
Just, you're going to not be able to get the marks for show your thinking. Now, if I play 0 games, I walk in and I walk up to my buddies who are bowling, but I haven't actually bowled yet. How much do I pay? No. $3, because they're not going to let me walk up to my buddies in my regular shoes. Everybody cool? If I play 1 game, do I pay that $3? Indeed I do. And then I pay how much more? $2.50 for 1 game, yes? What if I play 2 games? Do I pay that $3? Do I pay that $2.50? How many times? Twice. What if I play G games? Do I pay that $3? Do I pay that $2.50? Times what? G. Does this number times a variable look like that? Do I have my answer? So, what is it? C, cost, but I chose not to use X. What did I use? G for games equals 2.50 times G plus how much? 3. That's the function. That's the thinking. It's worth 2 marks. Now stop. Are you allowed to have written it this way? 3 plus 2.50 G or X or Q or whatever. Is that allowed? Of course it is. Right? TJ. Everybody good? So that's worth 2 because I wanted to see how you got to it. Is it a function? Yes or no? Yes, that gets you 1 mark. Explain. Why? Isha. Every input, which is a game, gets you 1 output, which is a cost. Okay, it is 2 marks. It's 1 for the yes and 1 for the explanation. Nice job. And finally, for 1 mark, how much did it cost Angela to bowl 4 games? $13.
Dang.
Making that out of 5, and 3 is 8, making that page out of 8 diddly 8. All right. Now, guys, this question's a little hard in black and white, so I'm going to use some colors here. The pink line is pink visible. Is that showing up well on the screen? And the blue line. Is that showing up well on the screen? Okay, now, so who's blue, who's pink? Read the question.
I think Alaric is blue.
Alaric is blue,
Carlinda.
and Carlinda is pink, okay? Everybody cool with that? Okay, so question 1. For 2 marks, what is the initial height? What does initial mean? Starting height of each balloon. So, how far off the ground is my man Alaric? Isha. 10 meters. How far off the ground is Sister Carlinda? 30 meters. 1 mark. If you get them both. If you missed one, you get a half.
Yeah, you can't do that.
Everybody cool?
Yeah. Yeah.
Okay.
He's just mad because you see the genders.
Oh no, that was just dumb luck. Actually. I just grabbed pink. I couldn't remember who was who.
You said my boy Alaric, and he's like,
Alaric is a boy's name.
that's what you said.
No, Alaric is a boy's
Yeah,
name.
we know.
Okay.
Might just-
Now, how fast is each balloon rising? So let's start with my man Alaric, who is blue. How would I decide how fast he is rising? It's a speed, isn't it? So I need a distance over a time, correct? So I know Alaric is going up a certain amount. So if I go up to there and go over to there, I get a perfect spot, don't I? He went up from how far, where to where? 10 to 70. So how far is that? 60 meters in what? 4 minutes. Now, is that a 1, 2, 3, or a 4, do you think? That's a 3, right? That shows everything you need to know. He's going up a distance and over a time. What makes it a 4? Do we ever do speed that way? I drove 800 kilometers in 4 hours. No, we do single digits, right? So, if I change that, I could change that to what? 15 meters a minute would be a good way to do that. Sam says, well, let's do per minute. Because that makes sense. Kilometers per hour, meters per minute. So I divided by 4. So I divide by 4 up there. 15 meters per minute. Now, do you still get your 1 mark from me if you have 60 over 4? Yeah, you do. Because that's right. I'm not marking you. I don't run the show that way. If you give me a right answer, I give you credit for it. Right? So you get your, well, you're going to get a half there. Right? And how fast is Carlinda going? She goes from 30 to 70, which is how far? 40 meters in the same 4 minutes. That would get you the 3. And what gets you a 4? 10 meters per 1 minute. But you, of course, will get a half mark for each to get a total of 1 minute. Is everybody, or 1 mark. Is everybody okay? All right. Now, when are they at the same height? 4 minutes for a half mark. What is that height? 70 meters for a half mark. Can everybody read a graph? Sweet. You guys must have had a great Math 10 teacher. Oh, stop it. Just stop it.
Mathematician's even
I
better.
didn't have you such
Huh? You're in Math 10 right now, Nick.
Oh.
That's why it was funny.
Bad English.
It's a good thing I didn't have a sip of water there, Nick. That might have come out my nose. All right. Guys,
14.
last question. What does the graph represent? Yeah, flying from Toronto to Rome. That was pretty hard to find.
Oh, it says Toronto. I just said simply flying to Rome.
That 1 mark right there.
Waiting.
Yep, that's 1 mark.
What if I just said somebody flying to Rome?
No.
What? Huh? Yes. That would be fine.
I didn't see the Toronto.
Okay. What are the domain and range? Where is domain? Domain, does it have to be the x-axis? Be careful. Could I turn this graph sideways? Independent variable. In this case, the independent variable is time, and it is on the x-axis. So we're going to check there. What's the lowest one I can have?
0.
0. What's the highest one?
9.
9. Can I use this notation? Can I use that one? Yes, because there's always going to be a time, right? The jet isn't teleporting. It's flying straight there, right? Could I do this one? H9. Is that one okay? Yes. What's the range? It's tricky. Jack.
7100.
Oh! What number goes first, Jack? 0 up to what? I thought it was 7,200, but yeah, whatever, right? And how else could I write it? 0. What goes here? This shouldn't have been an H. That should have been a T for time, right? T. So what would go here? D for distance, 7,200. Cool? For 1 mark. And the last one. We only got like 2 minutes left in class. We got to go fast.
4 hours.
4 hours for 1 mark. Making that page out of 14?
No, that was
No, making that page out of 1, 2, 3, 4, 5, 6. Making the whole thing out of 6 and 8 is 14. And 13 is 27. And 3 is 30, 36. Whole thing's out of 36. Yo.
Does it have to be like that, or would that be fine?
Okay. I would give you half a mark here.
Yeah.
Because you looked in the right spot and everything, but this is saying that there's no input, there's no times from 1 to 2.
Okay.
But there is a time from 1 to 2, right? Because you can see there's still an output.
Yeah.
Picking up what I'm putting down, so I give you half. Everybody good? Okay, whoa. We didn't get to talking about the big test thing that you got to do at the end of next year. That's what we're going to do tomorrow. We're now finished functions. When would the test be? You know I don't like the tests on Friday. It could be as early as Monday. It depends. I don't like to, but I will. I like for you guys tests on Mondays and Wednesdays, because then if you need extra time, it goes to after school.
One announcement before you end today.
Quiet.
Immunization form, please come to the office.
Oh.
At the end of the day. Please fill these forms out and then hand it in